The table below shows the growth of a local university. So we have the year, 1997, 1998, and so on, and the enrollment starting with 8,500, 9,003, and it keeps increasing from there. Make a scatter plot, and then create the regression line, determine the equation that best fits the data, and it says the years are the x-coordinate, and the enrollment is the associated y-coordinate for each year. Okay, so let's see how to do this on the TI. I'm going to bring it over here. So first we're going to, let's turn our stat plot on. So press second y equals. I'm going to press enter. Going to do a scatter plot. So type, this first one selected. X list is L1, Y list L2. It doesn't really matter what the rest of it is. Okay, so let's go ahead and put the data in. So press stat, edit. And then in L1, put your X. I've already done that. In L2, put your Y. Now to graph it, you're just going to press zoom and then scroll down to number 9, or just press number 9, zoom 9. Let me remove, looks like I've already done this. I'm going to go ahead and clear that equation out. You will not have an equation on there. So there we go. So this is what your graph should look like. So almost perfect linear, right? It's got a little, it comes down a little bit on this last year. So we want to find the line that best fits this. So it appears though, as time goes on, as X increases, the year increases, my enrollment increases. That's a positive association, a positive relationship. So let's run a regression on this. Press stat, scroll over to calc, and you're going to press number 4. There we go. X list L1, Y list L2. We can leave frequency blank. Store regression equation. You have an option here. I like to see that equation, that line, zip onto those points, like you saw when I had it on there earlier. It takes a few keystrokes, so completely optional. I'm going to press vars, scroll over to yvars. It's a function, and y1 is where I'm going to put it. And then I press enter, and then press enter again. It's going to calculate my regression equation. So it's going to be y equals, here's my slope, 416.976x minus, what is that, 824,089.619. So that's my equation. It also gives you the R, the correlation coefficient, in this case 0.995, very high of course, and the R square, called the coefficient of determination, at 0.99. So 99% of the variability in enrollment can be explained by the variability in the year. Again, very high. So if you do not see R squared and R, your diagnostics are turned off. We need to turn them on. And it can be found in a couple of places, depends on your calculator model. If you press mode, and if your mode looks like this, the diagnostics are in there. If you come all the way down here to statistics diagnostics, yours is probably on off, just toggle it to on and press enter. If yours doesn't look like this, you can press second catalog, and you're going to scroll. These are alphabetized list of everything the TI can do pretty much. Scroll down to diagnostics, so I'm just going to press, I can go ahead and press D. It'll scroll down to the D's, and then I can just scroll a little bit until I get the diagnostics on. Press enter, and then enter again. Now when you rerun that regression, stat, calc, number 4, enter, 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 enter. You should see R squared and R. And when I graph it, there's that line that goes through, and it looks like it fits them pretty well. So I hope that helps.